And the next thing is transpose of a matrix, transpose of a matrix, or transposition of a matrix. Okay, the matrix A raised to power t is obtained. We call it A transpose of this matrix is obtained by interchanging rows and columns of the matrix A. The matrix A transpose is called a transpose of matrix A in general. If A is an M by N matrix, then transpose of A is N by N matrix. So what you do is that you interchange the row and the column. So if you look at here, M by N, but if you find the transpose, it will become N by M. Okay, e.g., we have let A equals to this matrix, then the transpose of matrix A will be, we have A11 here, and then A12. Discover that this A11 is the first row, so this one will form the first column if you are finding the transpose. So that is why we have A11 and A12 is a row here, but if it is under transpose now, discover that if that first row become the first column, then the second row become the second column. Just for you to interchange it like that. Okay, or if C, matrix C is equals to all of this, then the transpose of it, you see, the first row will become the first column, the second row will form the second column, then the third row will form the third column. So that is how to interchange it. If you can be able to do that, you'll find the transpose. Example 1, let A equals to 3, 2, 1, or let A equals to this matrix, B is equals to this matrix. So find the transpose of matrix A, find the transpose of matrix B. Is the transpose of A, B, or the transpose of the multiplication of these two matrices, the transpose of it, is it equals to transpose of A times transpose of B separately? That is the question. Then the next question is the transpose of A and B all together, their transpose, the transpose of their multiplication, is it equals to the transpose of B, matrix B, and transpose of matrix A? Remember, here A comes first, here B comes first. So we are going to find out. Solution: the transpose of A, you see, first of all, matrix A is this. The first row become the first column. Look at it here. Then the second row become the second column. You have found the transpose. And then transpose of B, the first row 2, 3, 6, see, will become the first column 2, 3, 3, 2, 6 rather, 3, 2, 6, 3, 2, 6, 7, 3, 0, 7, 3, 0. See, this there is the second row become the second column, and the last row become the last column. So that is how to find that transpose. Okay, so the multiplication of AB. All right, before we find the transpose of AB, we have to multiply AB first. This is our A, this is matrix A multiplied by matrix B. By the time you do this multiplication, you discover that you are going to get 19, 17, 19 this. I am not going through the rigorous way of multiplying because you must have watched my video on how to multiply matrices. If you have not learned that, how I got this place, go and learn how to multiply two matrices together in my previous videos. It's already there. Okay, so if you have gotten this matrix from the multiplication of these two matrices together, then the transpose of this is going to be this. Why? Because the first row in transposing is going to become the first column. This second row will form the second column. That is how to find the transpose. Then if you are looking for the transpose of the multiplication of the transpose of each of these matrices, first of all, we have already found the transpose of A and the transpose of B. The transpose of A is this. From up here, you discover that the transpose of A is this. Then the transpose of B is this. So we want to multiply this and this together now. And that is what we have here. Look at it here. Transpose of A is this. Transpose of B is this. Now, look at it. It's not conform So A, B, all transpose is not equals to A transpose times B transpose. Why is it not conformable? Remember, we told ourselves from the multiplication of matrix that before you multiply two matrices together, the number of row of the first matrix must be equal to the number of column of the second matrix. So how many rows do we have here? 1, 2, 3. Okay, so now this row we have here, you discover that it is not the element in each of these row is not equivalent to the element in each of the column. So we have 1, 2. In this first column we have 3. So it is not, conformable. All right, it's not. So we can multiply them together. So B transpose multiplied by A transpose, can they go? Yes. You see the entry of this row is an element there is equal to this element. All right, so by the time you multiply these two matrices, you are going to get this final answer. All right, by the time you have this final answer, then you discover that this transpose here, you have 19 minus 3 and then down to 26 here. Therefore, we can conclude that AB, all of them in transpose of A multiplied by B is equals to separate transpose of B multiplied by transpose of A. Why is it so? Because this give us this. Then let's find out what AB, transpose of A multiplied by B, give us. Look at it. We find it here. 19 minus 3, 17, 15, 19, 26. And then if you do them separately here, they were able to give us the same thing. So discover that this is equals to this. So in general, if the matrix A and B are conformable, then A, B, and all their A multiplied by B, matrix A multiplied by matrix B, all and its transpose will be equals to the separate multiplication of the transpose of B coming first and then A coming later. If A comes first, it is not going to work, like in this case. Discover that A comes first, so it will make the multiplication of the matrix invalid.